Hi folks, in this video we're going to talk about how Le Chatelier's principle applies to temperature. Now there's a few things worth noting about temperature before we get too far into this reaction. In most cases we'll have reactants. There's two ways really of representing temperature in reactions. We'll have reactants, products, and then there's two ways of representing it. One of the ways is by including just like a delta H at the end of the reaction. The other is by including the delta H as part of the reaction. Plus delta H goes to produce products. For my personal experience, I find it easier to represent the reactions like this. And so what we need to know then is that if we have a negative delta H, we have a reaction that is exothermic. And so we can say that the delta H is a product of a reaction. If we have a positive delta H, we can say that this reaction is endothermic, meaning it requires the input of some energy in order for that reaction to occur. And so we can say that our delta H is a reactant. And so when we're looking at questions that look exactly like this one here, what we'd want to do is we'd want to translate this delta H at the end and rewrite our reaction with the delta H included as a product or a reactant. And that'll make solving these Le Chatelier questions a lot easier. So here we have a positive delta H, and so we know this is endothermic, and we also know that this will occur as part of the reactant side. So we're going to add in 58.0 kilojoules as part of our reactants, and then we're going to form two NO2s, and those are in the gaseous state. And so now what we can start to see is we can treat this as though it were a concentration question, where we can draw our seesaw and figure out what side is going to be more favored in this question. So in the scenario that I've given you, I've said, what would happen to this reaction if I increase the temperature? Well, if I'm increasing this side, what that's doing to our seesaw is adding more weight to the reactant side. So if we look at this and we add more weight to the reactant side, we're looking at this. And because this elbow is pointed up, we know that this reaction is going to be shifting to the right. This reaction is going to be shifting to the right. And so what we know then is that if this reaction is shifting to the right, the forward reaction is happening more, meaning we're going to have an increase in this amount of NO2, and we will see we have a decrease in this amount of N2O4. Again, we haven't changed the amount of N2O4 present. All we've done is just add more heat in, and that is what temperature looks like when it is applied to Le Chatelier's principle.